Two integrals involving poly-logarithm function. So basically in this video we will integrate these two functions using the poly-logarithm function, and basically even the special case of poly-logarithm function, which is li2 of x, we will use this thing. Okay, now let's go with the second one because the second one is easier. And for the second one we also need the logarithmic expansion of tan h inverse x, yeah, which most of you might know that it's 1 by 2 ln of 1 plus x by 1 minus x. Yeah, with that tool set the integral becomes 1 by 2 ln of 1 plus x minus ln of 1 minus x by x. Yeah, now we also know that the li2 of x is actually integral from 0 to x of 1 minus, sorry, not 1 minus, I mean to say minus ln of 1 minus x by x dx. Yeah, now since this integral is 0, yeah, at x equals to 0, yeah, so this basically the entire derivative also evaluates to 0. Yeah, this li2 of 0 is also 0 because from the sum of li2 of s we know that its sum from n equals to 1 to infinity of we will have g to the power n by n to the power, this is 2, not s, okay, if it's g over here. So we know that li2 of 0, this sum will just have 0 over here, so it's also 0. So that's why this integral can just be written as antiderivative of minus ln of 1 minus x without any boundaries by x dx. Okay, so we have this thing. Now if we use that, first of all let's manipulate this into that form. So minus ln of 1 minus x by x minus of minus ln of 1 minus minus x by x. Yeah, now it's in the form that we want. We know that now we know that this is just li2 of x, yeah, minus this integral is also li2 bit of minus x, and so this is the solution, yeah, for the problem. Now let's go to the next problem. Next problem is somewhat nice than this problem because this was straightforward and just the use of the tool, but this one is a good problem. Okay, so basically we have integral from 0 to 1, and since there's li2, so we will have sum from n equals to 1 to infinity, and so we will have root x to the power n by n to the power 2 because there was a 2 here. Now for this we can now change the summation integral from the dominated convergence theorem. This will have x to the power n by 2 by n square dx. Now let's integrate this. Sum from n equals to 1 to infinity x to the power n by 2 plus 1 by n square times n by 2 plus 1 from 0 to 1. Yeah, so we will have sum from n equals to 1 to infinity, 2 can be taken up. Yeah, so basically at 1 this is just 1, at 0 this is 0. Yeah, so we will have 2 by n square times n plus 2. Yeah, and then minus 0, so it doesn't matter. Now what remains is to evaluate this sum. Now for the sum we can use partial fractions. That's somehow a difficult task because it involves a lot of work, but let us do it. 2n square n plus 2 is equals to a by n plus b by n square plus c by n plus 2. Now if we just take the LCM, we have a times n plus 2 plus b times n plus 2 plus c times n square. Now substitute n equals to 0, we get 2 equals to 2b. That's why b is equals to 1. Substitute n equals to minus 2, we get 2 equals to c times 4. So c equals to 1 by 2. Yeah. Now substitute n equals to 1, we get 2 equals to 3 times a plus 3 times b plus c. 2 equals to a is not known, b is 1, so 3, c is 1 by 2. That's why 3a equals to minus 1 by 2, 3a equals to minus 3 by 2, so a equals to minus 1 by 2. Now we have the partial fractions. Yeah. So basically the partial fraction is sum going from n equals to 1 to infinity. Yeah. Now for n, a we have minus 1 by 2, n plus for b we have 1, and square plus c we have 1 by 2, n plus 2. Yeah. Now we can just recombine these. This one is just remain zeta of 2 and take half and sum from n equals to 1 to infinity. Now this is just 1 by n plus 2 minus 1 by n. This is a kind of telescoping sum. Yeah. So now telescoping sum are not that hard to evaluate. Those are easy stuffs. This is Riemann zeta of 2 plus the other one is 1 by 2. Now let's see what do we get. 1 by 3 minus 1 by 1 plus 1 by 4 minus 1 by 2 plus 1 by 5 minus 1 by 3 plus 1 by 6 minus 1 by 4, and this goes on. Yeah, we can see that 1 by 3 cancels out, 1 by 4 cancels out, 1 by 5 also cancels out, 1 by 6 also cancel out. So the what remains is just these stuffs. Yeah, so we have Riemann zeta of 2 plus 1 by 2 times, this is minus 1 by 2, so that's minus 3 by 2. So yeah, we are left with Riemann zeta of 2 minus 3 by 4, and that's the answer. Yeah, so that is the answer. Hope you got the solution. It was just some integrals, yeah, the definition, and it immediately went into telescoping sum. So this was a lot easier, and this one also was easier, just to use the definitions and nothing more. Yeah, hope you enjoy the solutions, and I will come back with more tougher problems next time. And yeah, look forward to seeing you in upcoming videos too.